For these last set of notes, we're going to talk about the properties of equality and then how we use those in a two-column algebraic proof, which we're going to learn more about as well. So these first couple ones, we have addition property, subtraction, multiplication, division property of equality. And what that means is if we have an equation, so A equals B, and then the next step that you would see then for addition property is you would be seeing something being added to both sides of the equation. So in this case, we are going to add another letter, and that would be C. So the plus C would be the part that you see that's added on, and that's why it is the addition property. So subtraction property is going to look similar, and same with multiplication and your division property. For the subtraction property then, you will see something being subtracted off of both sides of your equation. For the multiplication property, you are going to then see something being multiplied onto both sides of your equation from the original statement. And then lastly, for the division property, you are going to see something being divided from both sides of your equation. For the distributive property, you are going to see that one step that it gives you the original problem, and then the next step they're going to do something with it. They're going to simplify that. So remember, when we have the distributive property, we can take A times B, and then we can also take A times C. And sorry about that equal sign, it should be a plus in between the two of those. Then for the substitution property, if we start with the A equals B again, and then just think of the word substitute. If you have a substitute for one of your classes, they're replacing your teacher for that day. So if we have the substitution property, we are going to have one of our variables, so let's just say A. So in our original equation, we might replace the letter A with something instead. So then what it could look like is if I take the A and I replace it with the B, then it could end up being B equals B for the final sentence. Now, usually it's not going to end up being the same number there. Reflexive property is for any real number A equals itself. So if you ever see something where it says the same pieces on both sides, and that will happen quite often, that you will say that that is the reflexive property. And a value will always equal itself. So if you have an actual number there, you need to make sure it equals the actual number. Otherwise, it would just be the name of the segment. Symmetric property is, think of it symmetrical. So a butterfly is symmetrical, or a Valentine heart is symmetrical, which means it is the same on both sides. So even if you switch the order of it, it is still the same. So symmetric means that we can write it one way, and then you could write it the opposite way, and your reason why is because of the symmetric property. Next, we have the transitive property, and the transitive property is if we start with some equation, and then we have another equation that talks about the letter B, so whatever the B value is, and say that it's now equal to C. Well, just like with our law of syllogism, with our sentence structure, we can tie this first to the last. So then we can say that A equals C. So I could say that if x equals 5, but 5 equals y, then I could really say that x equals the y as well. So how we're going to use this is in an algebraic proof, and it's called a two-column proof, but we're going to use it using algebra. So in a two-column proof, it's a common format used to organize a proof. And on the left side, if you look down here, we've got two different columns. On the left side, this would be a list of the statements or the steps. And that would be the steps to actually solve the problem. The right side then, you are going to be listing out the reasons that justify each step. Now remember, I've said this before, but geometry is a lot about the reasons on why you are doing certain things. You can't just tell me the answer anymore. You need to explain the reasons and how you got there. So the question is, what can be used as a reason? And that would be any properties, any definitions, postulates, and finally you can use any theorems. For number 1, we have our original problem, and we have 4x minus 1 equals 27, and they will tell you what the proof statement is going to be. So in the end, we want to prove that x equals 7. So on these, the steps are already done for you for the statements, but we need to put what is the reason and how we can get from step 1 to step 2, how do we get from step 2 to step 3. So how we get step 1, that is the given to us, so that very, very first step will always be given. Now you need to ask yourself, how do they get from step 1 to step 2? Or how do they get step 2 from step 1? And if you notice, if you had step 1, I would add 1 to both sides, and yes, that gives us step 2. So what did I do to both sides? I added. So my reason would be the addition property of equality, because it ties in with what I did to both sides. That tells me my reason. So now for step 2 to step 3, so same question, how do I get step 3 from step 1, or sorry, from step 2? So how am I going from step 2 to 3? Is I would divide both sides by 4, and then that tells me what my reason is going to be. So since I divided on both sides, that would be the division property of equality. On the second page, we're going to jump all the way down to number 4, and the first stop, remember, is always the given. So now how do we get from step 1 to step 2? And you have to look at what is different. So my 7 stays the same, so it's not that. So the question is, how do I get this 2? And the 2 is on the right side, but it started as an 8. So they had to move the 6x to the right, and how do we move it over? We had to subtract 6x from both sides. So our reason would be our subtraction property. And it's our subtraction property of equality. And I'm going to start abbreviating that as well, and you probably will as well. So then for step 3, I want to ask myself, how do I get to step 3? And the part that is different is not the 2x, but it's this 24. So how do I take the 7 and the 17 to get the 24? And they move the 17 over by adding 17 to both sides. So that tells me that my step would be my addition property of equality. For step number 4 now, I want you to do this yourself. So how do they go from step 3 to step 4? What you should have put was the division property, because they had to divide both sides by 2 to get step 4. This last one is a little tricky, and the reason why is because all they do is flip-flop the order. And what is the reason that we can rotate the order of both sides of our equation? And that is the symmetric property. So just real quick on number 5, there's just a few things that might show up that are a little bit different, and that's on one of the first steps in number 5. And if we have our step 1 and we want to go to step 2, the biggest thing is to get rid of the parentheses, and when we get rid of parentheses, that's because we distribute. This next one is sometimes you might not know exactly what to write for it, but the parts that are different is, let's see, our 4x and our 7x is the only thing that's different. And what is that called when you are combining like terms? Is you're really just simplifying. So you can just write simplify for number 3 of how they combine their like terms. Now for the last few steps, we have the subtraction property, because they subtracted 12x from both sides. Then we have the addition property, because they moved their negative 14 over by adding it. And lastly, they have the division property, because they divided by negative 15. Remember that there's lots of other possibilities of what we could use on the right side for the reasons, but these are the main ones that you will see.